Question number 64, we have a 20 microfarad capacitor joined to a battery of 6 volt to a resistor of 100 ohm. We need to find the charge on the capacitor 2 milliseconds after the connections are made. So this is the circuit. We have a 20 microfarad capacitor and a 6 volt battery, and it's connected to a 100 ohm resistor here. So we need to find out the charge on it after a certain time, t equal to 2 millisecond, after a time of 2 millisecond. So when you connect a battery like this, the charge slowly start accumulating in it. So initially the battery is 6 volt, the voltage here is 0 volt. So as soon as you connect it a little bit current flows, and let's say the charge on it increases, and as a result this voltage becomes 1 volt. So the voltage across this resistor will reduce and the flow of the charge will reduce because the current reduces. The formula for this charge accumulation on this capacitor is given by Q is equal to Q naught 1 minus e to the power minus t by RC. If you think that you made a mistake in this formula, you can check it, do a sanity check. This is, I am showing a graph of variation of Q with respect to time. So Q is actually Qt, which means that Q is varying with time. So when t is equal to 0, this whole terms become 0, and e to the power 0, this whole terms become 0, and e to the power 0 is 1, so 1 minus 1 is 0, so Q becomes 0. When t is equal to infinite, this is 1 minus 1 upon e to the power infinite, or 1 upon infinite, which is 0, so 1 minus 0 is 1. So as t tends to 0, this Q is equal to Q naught, or final stable voltage. So that's how we verify that the formula is correct. Now Q naught is the final stable voltage. It's given by CV, where V is this voltage and C is the capacitor. V is the final stable voltage delivered by this battery. So we can find Q is equal to C is 20 microfarad and V is 6 volt battery here. 1 minus e to the power of minus t is 2 millisecond, 2 to the power minus 3, divided by R is 100 ohm, and C is 20 microfarad, 20 to the power 10 to the power minus 6. 10 to the power minus 3 and 10 to the power minus 6 becomes 10 to the power minus 3 here, it goes up, becomes 10 to the power plus 3. 10 to the power plus 3, and this 0 and these 2 0 cancels. And this 2 cancels with this, so we get e to the power of minus 1. This becomes 10 to the power minus 6, let's take it out and say it's a microcoulomb. And this becomes 120. 120 multiplied by 1 minus e to the power minus 1. 120 multiplied by 1 minus e is 2.71. We can write it something like this. So 120, 2.71 minus 1 is 1.71. 1.71 divided by 2.71. Let's remove this guy, it becomes 1.7 by 2.7. Divided by 3, 3 into 9, 3 into 4, 0, 40. So this becomes 40 into 1.7. 17 into 4 is 68 divided by 0.9, and this becomes 68 divided by 0.9, roughly 75.5 microcoulomb, or you can write it as 76 microcoulomb.